Jai Hind and welcome to all. Myself Shiwani from Applied Science and Humanities Department in Ajay Kumar Garg Engineering College. Will continue the concept of phase rule. So, in this lecture we will discuss the application of phase rule for one component, that is water system, and this is a fifth lecture of unit 3, that is electrochemistry. The books are same, the references are same. So, application of phase rule to one component system. So, before application, if we just remember that what is the phase rule, or in previous lecture what we have discussed. So, it is F is equal to C minus P plus 2, that is phase, P is phases, C is component and F is degree of freedom. Okay. So, in case of water system, we know that the water exists in three forms: solid, liquid and gas, and in any form the water is always expressed as H2O. So, it is a one component system. So, for water system C, it will be always 1. Now, there are three possibilities. First, either solid liquid is in equilibrium, liquid vapor 2 is in equilibrium, or solid vapor is in equilibrium. So, for water system we can say either H2O solid is in equilibrium with H2O liquid, or we can say H2O solid may be equilibrium with H2OV vapor, and third possibility it may be H2O liquid in equilibrium with H2O vapor. Okay. So, these are three possibilities. So, in this case, and one another possibility is all three phases coexist in equilibrium, and for water it is called triple point. So, it means for a one component system C is always 1, and if P is 1 means single phase exists, it means either solid or liquid or gas. So, in this situation when we calculate F, so it will be C minus P plus 2, which is 2. That is, two variables are required to define this equilibrium or to define this system. So, temperature and pressure both are required. Now, second case, if P is equal to 2, P is equal to 2 means these three cases. So, in these cases when we calculate degree of freedom, it will be 1. Degree of freedom 1 means one variable is required to define the system. This variable, it may be solid, it may be temperature or pressure. It means to define this equilibrium or this, only one variable is required. Now, next it may be when P will be 3. Phase 3 means triple point, that is all three phases coexist in equilibrium. So, in this we get F is equal to 0. F is equal to 0 means it is fixed, nothing is required. So, this point occur at fixed temperature and fixed pressure. Now, suppose P is equal to 4. There may be a possibility that 4 phase coexist in equilibrium, but for this condition when we calculate F, so F will be in minus, and we know that F value in negative value of F is not possible. That is, in one component system it is not possible that 4 phase coexist in equilibrium. So, we get only these three possibilities on phase 1, when phase 2 and when phase 3. Now, when we draw the phase diagram, so before phase diagram, if we check the behavior per pressure and temperature, that from Clausius-Clapeyron equation, and which is dP upon dt is equal to delta H upon T into change in volume, we can say delta V, or we can say V2 minus V1. So, delta H upon T we can say entropy. So, it is delta S upon delta V. So, since there are three equilibria First is in between solid to liquid, in between liquid to vapor, and third in between solid to vapor. So, for second and third, when liquid change into vapor, then the randomness increases, and again delta V get also positive. So, in this case the dP upon dt, it will be positive. So, that is when we draw the phase diagram, and since the phase diagram is draw P versus T, then the slope it will be dP by dt. So, for both two cases the slope will be positive, and the slope value, this will be, this slope it will be more steeper than this. Now, for first condition, that is for 2 we get this type of slope like this, but for first, that is solid to liquid. So, in this case, for generally liquid, for simple liquid, we know that when solid convert into liquid, the randomness increases. It means the dP upon dt, it should be positive. But for water, we know that when ice melt, it shows different behavior because of cage-like structure of ice. That is, the volume or it become contract, and when it become contract, the randomness it get decrease. That is, for water system, the slope is in between ice to liquid or ice to water, it will have negative slope. So, I think it is clear that for second and third case, slope it will be positive, but for first, for water system, the slope will be negative. So, in phase diagram we will draw or we will discuss these three phases. Now, let us discuss one by one. So, the phase diagram of water, the phase diagram of water, it contain or it will contain three curve. One is OA, OB and OC. It is not necessary that we write OA, OB, we can point any alphabet, but there will be three curve with respect to all three phases, and in these two curve, the two will have positive slope and one negative slope, and one triple point. Triple point means the point where all three curve meets, that is the point where all three phases coexist in equilibria, and third possibility where only one phase coexist, either AOC, AOB or BOC. We will discuss one by one. So, let us first start from vaporization curve OA. Suppose this. So, there are three curve, one OA, second OB and third OC. So, let us start this curve. So, along this curve we can see that if we increase the temperature with pressure, that is the water it get boiled. It means along this curve H2O liquid is in equilibrium with H2O vapor, and since the liquid convert into vapor, so we can say this curve is vaporization curve of liquid or water. Now, when we see the second curve OB, it means below this point O up to absolute 0 temperature, we can easily see that this solid is in equilibrium with vapor and both have positive slope. Now, when we discuss about this curve, that is along this curve, and this process is called sublimation. So, we can say this is sublimation curve, and along OC, here we see that on increasing the pressure, the temperature decreases, means it is, that is ice melt, or we can say it is fusion curve. So, along OC we can say solid is in equilibrium with liquid, solid is in equilibrium with liquid. this. And it has been already discussed that for any curve, whether it is OA, OB or OC, the degree of freedom will be 1. Degree of freedom will be 1 means if along this curve, if we know the temperature, we can easily find what is the pressure. For example, the temperature is 100 degrees centigrade and we know that this is the vaporization curve. So, definitely at boiling point, the vapor pressure, it should be 1 atmospheric pressure. So, let us discuss one by one. So, first is curve OA. The water at any given temperature is associated with vaporization with increase in temperature. That is, there is a increase in vapor pressure. The rate of increase is higher at higher temperature than at lower temperature. That is, it represents the equilibria between water to water vapor, or we can say liquid to vapor, and this is called vaporization curve. And since the degree of freedom is 1, so it is called univariant system. So, first when we draw the phase diagram, so at x axis this is T and this is P, and when we draw the phase diagram, so we starts from O and this let A. Here we see that this curve starts from O and it extend or it end up to A. It means beyond this point the liquid will not be there, that is the liquid will merge into vapor, and this point is called critical point. So, this point it is critical point and which is approximately 374 degrees centigrade, and beyond this temperature the equilibrium will disappear, only water vapor will exist. Now, second is OB. OB means this. So, along this curve solid is in equilibrium with vapor, or we can say ice is in equilibrium with vapor, and this represents, since this represent the equilibrium between solid to vapor, so this is called sublimation curve, and this curve it can be extended also below B, and since along this curve the degree of freedom is 1, so we can say it is also univariant system. Now, third curve is important, and since for water system, because of cage like structure, it shows different behavior. This curve OC. So, third is fusion curve or melting point curve. So, this curve it represent the equilibrium between liquid to vapor, solid to liquid, that is ice to water, and here we see that this curve it slopes towards the pressure axis. Here it is clear that it basically slide towards the pressure axis, and which indicate that the melting point of ice it decreased by increasing the pressure, and when we apply the pressure on the ice, here we see that it get melt, that is its melting point get decreased, and ice occupies more volume than water because of its structure, and whenever pressure is increased the ice melts to form water, and which is accompanied by decrease in fusion temperature. And when we find the F for any curve, we know that F is 1, so it is again univariant system, and this curve is again extendable beyond C. So, 3 curves are clear. First is vapor pressure curve, second is sublimation curve, and third is melting or fusion curve. There is another curve which is a metastable curve, and this curve is also called supercooling curve. So, if we extend this O up to this point. So, this is called supercooling curve and which is mentioned at C dash. So, water always, we know that water always does not freeze at 0 degree centigrade. So, if the vessel contain water and vapor is perfectly clean, free from dust, then it is possible to supercool water below its freezing point and avoiding its solidification. So, this curve, it represents the vapor pressure curve of supercooled water, and this curve basically it is shown by dotted line and which is show the it is a metastable curve, and a slight disturbance or slight impurity or slight addition on this curve, it will merge into OB. So, curve OB dash or we can say OC dash. This curve is called vapor pressure curve of supercooled water, that is supercooled water is in equilibrium with vapor, and where the following equilibrium will exist. The supercooled water vapor sometimes it can be freeze below 0 degree centigrade without the formation of ice, but this curve is quite unstable. So, it can be easily merged into solid curve. Now, the next is triple point. Triple point means a point where all three curves meets this point. So, the curves OA, OB and OC meet at a point O and it is called triple point. So, when we apply the phase rule equation and calculate the F, it will 0, which we have discussed previously. So, here we see that the three phases can coexist in equilibria only at fixed temperature and fixed pressure, and fixed temperature is and if we want exact reading, so it is 0.0098 degree centigrade and pressure is 0.006 atmospheric pressure or 4.58 mm Hg. So, the triple point of water is this and it is non-variant, and system changes from non-variant to univariant when any, that is either pressure or temperature is changed. It means a slight change in temperature or pressure. In three phases, the one phase will merge into another, because at triple point we know that ice is in equilibrium with liquid and liquid is in equilibrium with vapor. So, if we increase the temperature, then this point, that is this phase, it will merge into liquid, that is only two phase will they be there. So, that is this point get changed or it will merge in the curve. So, triple point is the property of extremely pure system. Now, next is area. So, if we discuss about the area, so there may be a three area. First is this which is AOB, second is this which is BOC and third is this which is AOC. So, it represent the ice, water and water vapor. And how we find this, which one is for which phase? So, AOB. So, in case of AOB, we see that temperature, on increasing the temperature, the pressure get increased, that is it is for water vapor. Now, for BOC, BOC means it shows reverse behavior, that is it is for solid. So, automatically third will be for water. And if this point is not clear, we can mention the equilibria. Here equilibria is liquid to vapor, here equilibria is solid to vapor, and here equilibria is solid to liquid. Now, we can take the common. So, for this common is V, for this common is L, and for this common is S. So, in order to define the system at any point in the areas, it is essential to specify both temperature and pressure, because here when we find the F, so F will be 2. F will be 2 means we have to define the temperature as well as pressure. So, the system is bivariant. So, this is the combined diagram, phase diagram. So, this is the combined phase diagram, and here we can write suppose B dash, because it will be B dash will be more convenient when we explain this. So, first OA. So, in exam no need to draw slight different curve or separate curve. So, when we write this question in exam, so draw a combined curve, combined diagram, and then explain one by one. And for good better resolution, we can write here H2O, liquid to vapor, and name here also vaporization curve, and 1 point 100 degree centigrade. So, the automatically pressure will be 1 atmosphere, and then this H2O solid to H2O vapor and sublimation, and along this pressure, that is at 1 atmospheric pressure, if we note the freezing point, so here it should be 0. So, it will be 0 degree centigrade. And third, it is fusion curve. Fusion curve means solid to liquid. And this triple point we can write 0.0098 and 0.006 atmospheric pressure. So, this is the combined diagram of water system. Thank you.